Hey there, y'all. Today we're going to start Module E, which is our Radicals module. And we have a lot of sections to cover in Module E, and so we're just going to keep all of them individual, and if we end up combining some, you can still find all of the YouTube videos here. So we're going to go ahead and start with 6.1. This is kind of a shorter lesson, and I am going to show you some calculator tricks, so you might want to go ahead and grab your calculator just to have it handy. But today we're going to talk about roots and radical expressions, and mainly how do you find the nth root of an expression. So if you need to refresh yourself on some perfect square factors, I definitely would. Or if you need to look at some perfect cube factors, that will definitely be helpful. And I think we'll hit more on that in the next lesson. But knowing those are essential to this module, especially when we're trying to find a certain root of an expression. So this next slide here is really important. I would definitely take some time taking some good notes here because this is dissecting what a radical tells us. Okay, so it says here you use a radical sign to indicate a root, and that is totally true. Whether you're taking the square root, the cube root, the fourth root, the 16th root, you're always going to use a radical sign. Now, there are certain parts to the radical sign that tell you what root you are taking. So it says here the number under the radical sign is called the radicand. So I would look right here in my visual, because I'm a visual learner, as y'all know. So let's take this vocabulary and put it into a visual. So what's under the radical sign is called the radicand, and now this is really important. The index gives you the degree of the root. So the index tells you whether you're taking the square root, the cube root, the eighth root, etc. Now, we are going to dissect that index number, and we're going to look at two major cases. We're going to look at first if the index is an odd number. So if you are taking the cube root, if you're taking the fifth root, if you're taking the seventh root, etc. Okay? If you have an odd index, you will always get one answer. Okay? And the beauty of the odd index is that you can have your radicand be positive or negative and you will still get a solution. So the cube root of 27 would go to 3. The cube root of negative 27 would be negative 3. And the way that that breaks down is because 3 times 3 times 3 gives us that 27. And then same thing at the top. Negative 3 times negative 3 times negative 3 would give me negative 27. So when my index is odd, I will always get one real root. The second case is if my index is even. So if I'm taking the square root, if I'm taking the fourth root, if I'm taking the sixth root, okay, if my index is even, we have a different scenario here. So if your radicand is positive, then you're going to have two real roots. So for example, if I'm going to take the square root of 16, I would say I would get positive 4, but I would also get negative 4. And we've learned a lot about that when we were solving quadratics. Now, if your radicand is negative, then there are two imaginary roots. And again, we talked about this. So let's say we're taking the square root of negative 16. That goes to positive and negative 4i because there's a negative under the radical. So we know that we would get an imaginary solution. Okay. All right, so let's see how this would play out here, okay? Going back to whether your index is odd or even. So on this first one here, I'm taking the square root of 8. How do I know I'm taking the square root? There's an understood 2 for my index there. If there is no index present, you know you are taking the square root. So the square root of 8 breaks down into the square root of 4 times the square root of 2. So that gives me 2 square roots of 2. We practiced breaking down square roots in a couple modules ago with quadratics because we had to do the quadratic formula. So this should not be too unfamiliar. Now, the cube root of 8. We've also talked about cube roots when we did the sum and difference of two cubes. Oh, I totally forgot. This would be plus or a minus. Forgot about that. Sorry about that. This would just go to 2. I only get one real solution because my index is odd. And then same thing here with the cube root of -8. That would give me -2. I don't need the plus or minus here because my index was odd. And as you saw in the video, I remembered I needed the plus or minus here because that was an even index. So anytime you have an odd index, there's only one real solution. If your index is even, you're going to look for 2 solutions. Hopefully they are both real. So let's put this into practice here on problem number 1. It says, what are the real cube roots? Cube roots, that's essential here for the following problems. So we have 3 answers that we need to, or 3 questions that we need to answer here. So we have the cube root, that means my index is 3. And what I want to show you here is how to do this on your calculator. So if you're having trouble knowing the cube roots, you can go to your calculator. Let's get home. And then if you go to math and go to option number 4, this will bring you up the cube root. So then we can type in the cube root of 0.008. That gives me 0.2. So my answer here would be 0.2. I don't need the plus or minus, again, because my index was odd. The cube root of -1000, if you want to do this with your calculator, you can. We would want to encourage you to not do this with your calculator, but you should get -10. And then on the last one, the cube root of 1/27, that's the same as the cube root of 1 over the cube root of 27, which gives me 1/3. Again, I don't need the plus or minus here because my index was odd. Same thing on part B, except now we're dealing with the 4th root. So when I set these up, I'm going to have a 4 as my index, the 4th root of 1, the 4th root of -0.0001, and the 4th root of 16/81. So if you want to practice typing this in on your calculator, we'll start that with the second one because on this first one, the 4th root of 1 would just be positive and -1. Let's try doing the 4th root on this next one here. So on your calculator, we're going to type in a 4 first, and then we're going to go back to math. And then we're going to select option number 5. So that puts in the 4th root for us. And what are we taking the 4th root of? -0.001. Oh, whoops, sorry, I missed a 0, I think. Yes, I did. 3 zeros. 0, 1. And we get an error. No real answer. And that makes sense, right? Because we're taking the even root of a negative number, so that means we have no real solutions. We would end up with something imaginary. So that brings us to the last one, the 4th root of 16/81. Let's try this again. Type in a 4. Oh, we got to hit second quit. Let's type in a 4. We're going to go to math, go to option number 5, and we're going to type in 16 divided by 81. And we get a decimal. So if you go to math and hit enter and then enter, it'll give you the fraction. So our answer here is 2/3. But it's not just 2/3. It's plus or minus 2/3 because our index was even. Once you've got the hang of those, go ahead and pause the video and try the bottom equations on your own. Bottom problems on your own. And I will be more than happy to give you the answers here. So we're taking the fifth root. That would be 0. That would also be -1. And then the last one would be 2. And then here, what are the square roots? That would be plus or minus 0.1. No real solutions. And then plus or minus 6/11. Perfect. All right. This is the same thing here. What is each real number root? So we can go ahead and simplify these if we want to keep practicing. This should give you -2. On the bottom one here, you would say no real solutions because, again, you have an even an even index with a negative radicand, so you'd get no real solutions there. On this one, we would say plus or minus 0.2. And then on part D, we would say it's technically plus or minus 2. If you want to practice these here, you can. Real quickly, you should get -3. This would give you no real solutions, again, because even index with a negative radicand. This would technically give you plus or minus 7. And on this last one, again, you would have no real solutions because, remember, if there's no index, there's a 2 there. And with an even index and a negative radicand, you would have no real solutions. All right, let's step this up and make it a little bit harder because now we're going to throw in some variables. And this isn't too terrible. Once you see the shortcut and you kind of get the hang of it, it'll become second nature. So here we go. On problem number 3, it says, what is a simpler form of each radical expression? Okay, I don't have to technically do the plus or minus here because now I have variables thrown in and I'm not solving. So from here, we would say, what is the square root of 16? That would become 4. And then again, it's probably helpful for you to put your index there because in order to simplify the square root of x to the 8, we're going to ask ourselves, how many times can 2 go into 8? Well, 2 goes into 8 4 times, so that simplifies to x to the 4th. If you need a visual of that, so we have 4, 5, 6, 7, 8. We technically have 8 x's under there, right? And I think back in middle school, you were taught, like, the index tells you how many, like, groups you have to have. So, like, for every 2, you can take 1 out. So you have 4 groups of 2. So that's why this simplifies to x to the 4th. Same thing on part B. How many times can 3 go into 6? That goes in twice, so that gives me a squared. And then 3 goes into 9 3 times, so that gives me b to the 3rd power. And then same thing on this last one, that would give me x squared times y cubed. Now I want to take a second and do an additional problem because all of these worked out nicely and you're like, well, what if they don't work out so nicely, right? Right, I hear you. So let's do like the square root of 27 x to the 4th, y to the 9th. Okay. So we would go ahead and put our 2 there. And let's break apart everything that we have here. So let's say I'm going to take the square root of 27. I'm going to take the square root of x to the 4th. And I'm going to take the square root of y to the 9th. Let's break down the 27 first. That breaks down into the square root of 9 times the square root of 3, which gives me 3 square roots of 3. For the x to the 4th part, that would just simplify in one easy step to x squared. And then on this last one, again, we got to simplify. How many times does 2 go into 9? 2 goes into 9 4 times, but you have 1 left over. because 2 times 4 is 8. Of the 9, you take away 8, you got 1 left. So 4 of them came out, but I still had 1 left under the radical. So how would we write our final answer? We would say everything on the outside of the radical gets written together, so that would be 3x squared y to the 4th times the square root of the 3 and the y. I just wanted to throw that extra one in there just to help you be aware of what happens if it doesn't work out so nicely. If you want to keep practicing with this, we can try these here. This would give us 9x squared. This would give us a to the 4th, b to the 5th. And this last one would give us x cubed y to the 4th. Again, all I'm doing is dividing that exponent by my index. Okay. If y'all want to practice another one, I can make one up here of, we can say the cube root of 54x to the 7th y to the, let's say 14? Sure. Okay. So again, I'm going to start by breaking all of this apart. The cube root of 54 times the cube root of x to the 7th times the cube root of y to the 14th. So the cube root of 54 breaks down into the cube root of 27 times the cube root of 2. So that gives me 3 times the cube root of 2. 3 goes into 7 2 times with 1 left over, so I would have one of the x's underneath that cube root still. And then 3 goes into 14, let's say 4 times. And then you would have 2 y's left over because 3 times 4 gives me 12. So of the 14, I take out 12. That leaves me with 2. Now also notice here, when I'm writing my radical, I'm making sure that I have the correct index, because if I don't have that index labeled, I would the grader would assume that I was taking the square root. But in fact, I'm doing the cube root. So from here, to write your final answer, we're going to write everything on the outside together. And then I'm going to have the cube root of 2xy squared. Everything that was underneath the radical gets written together as well. If you want to keep practicing, we encourage you to do this slide. And I can give you those answers very quickly here. This would give you plus or minus 5, because you're taking the square root. This would give you plus or minus 0.4. This would give you no real solutions because you're taking the negative. Down here at the bottom, you would have 3b. This should give you a to the 4th, b to the 9th. And this should give you negative 5a. So on the last slide here, this will help you with the worksheet, I believe, for your homework, when we're talking about solving. So from here, as we always tend to do, we want to get the x by itself, but it's trapped by that 4th power. So the way to undo the 4th power is to do the 4th root on both sides. So again, we can type that in our calculator, and we would get plus or minus, because my index here is an even number, and we should get 2/5. On this next one here, I'm going to have to subtract the 5 first. So I get x cubed is equal to negative 125. And then again, to undo that cubed power, I'm going to do the cubed root on both sides. And since my index is odd, I should only get one answer, and that should give me negative 5. On this bottom question here, this is a really good one because it's a word problem and everybody kind of gets thrown off when we do word problems. So let's check it out here. It says the temperature C in degrees Celsius of a liquid T minutes after heating is given by the formula C equals 8 times the square root of T. So I'm going to go ahead and write that down. And it says, when is the temperature 48 degrees Celsius? Okay? By that question asking us when, we know we're solving for T because T referred to time, which was minutes. So I'm going to plug in 48 for C is equal to 8 times the square root of T. So if we want to get T by itself, we're going to have to divide by 8. So we get 48 divided by 8 gives me 6 equals the square root of T. And then just like we did before, we got to ask ourselves, what's going to undo the square root of T? Squaring it will undo the square root. So we get 36 is equal to T. So that would say 36 minutes. Always put your answer back in context. And if you need help with solving, we would be more than happy to help you. Just let us know how we can serve you best.